Hello and welcome to this lesson about problems with triangles. The learning target for this video is solving problems by using properties of triangles. And so when I'm talking about properties of triangles, I'm talking about how we can find their area, how we can find angles, how we can find perimeter, all that kind of stuff based off of a few simple properties. So what we're going to see are two different types of problems. To keep it simple, we have inside and outside problems. Now, when we're talking about inside problems, we're going to be talking about angles of triangles. And what's super duper important to remember and to know about triangles, if you don't already know, is that the angle sum of a triangle is 180 degrees. So in a triangle, regardless of what three angles you have, they better add up to 180. Outside, that just refers to area and perimeter. And we'll get into that a little bit later. But first, let's focus on inside problems. So when we're looking at stuff like angle problems, you're going to be given a triangle and you're going to be given a couple of the angles. You might have something like here is, it doesn't look like 50 degrees, so let's not do 50. Let's say that this is 80 degrees. Let's say this is 30 degrees. You have to figure out what that one is. Well, the way we go about this is we essentially, I like to use placeholders for this. A triangle has three angles. When we add them all up, it better equal 180 degrees. Well, one of them I'm not sure about, but the other two I am. I have 80 degrees and 30 degrees. So I can add these two together. And so my unknown angle, which I can now maybe start using a variable for, x plus 110 degrees is equal to 180 degrees. Subtract 110, use a mirror line, subtract 110 from the other side, and x has to equal 70 degrees. So here for the angle sum, we are using a little bit of our solving skills, solving equations, combining some like terms right here. But essentially the main geometric principle is that all three angles have to add up to 180. Now, the way we can make things a little more complicated is we compound or add in multiple layers to a problem. So for example, might see something like this. Where you only get one angle measure. But the thing is, they embedded a second angle measure right here by doing that. And so what this means is that, again, we have our three angles, and they have to add up to be 180 degrees. They're telling us one of these is 90 degrees. That symbol means 90 degrees. So we have 90, we have 25, and then we have the unknown angle, x. So in this case, a couple ways we can go about it. We can treat it like this, or we could also think, if this is 90 degrees, and the other two have to add up to make it 180, that means that these two have to be 90 degrees. However you want to do it, it's up to you. I'll continue the same method just for the sake of consistency. So I'll combine my 25 and 90, so I get x plus 115 is equal to 180. Get my mirror line, subtract 115, subtract 115. And here I have x equals 65 degrees. Perfect. So those are the inside type of problems, where angle sum, 180 degrees, find the missing angle. One more thing. They might do something where like you have an isosceles triangle, and so that means that these angles are the same, these angles are the same. So from there, you might have a couple different things. You might be told like, hey, that's 30 degrees. What does the rest have to be? Or maybe you'll be given one of these, and you'll be like, hey, this is 50 degrees. What does the rest have to be? Same principle. You can start being like, well, if this is an isosceles triangle, that's 50 degrees, then I have to figure out what this is. Or whatever I find out that my 180 minus 30 is, it has to be divided into two equal segments there. So you could have to do some problem solving on top of that. Now, let's talk about perimeter and area. Perimeter is the basic one. So perimeter, we just have to remember, is essentially the sum of side lengths. So let's get a triangle. 3, 4, 5. Find the perimeter of it. perimeter is going to be equal to 3 plus 4 plus 5. In other words, the perimeter is equal to 7 plus 5, which is equal to 12. So perimeter here is 12. We'll talk about how this could get a little more advanced later on. Perimeter gets a little more complicated when we start looking at other shapes. But now, area, this one is a little more complex. So here, we need to know a formula. If you do not know it off the top of your head, now's the time to write it. Area is equal to 1/2 base times height. Now, keep in mind, there's little multiplication dots in here. So everything is being multiplied together. And so what this means, or what this looks like, is let's say we have a triangle. And let's start off with a right triangle because that's the easiest one to work with. This part would be considered our height. It has to have a right angle to the bottom. So there's our height, here is our base. We take these numbers and we multiply them by 1/2. So let's just say that here this was 6 and that this was 4. I would go 1/2 times 6 times 4. And so this, I could do it several different ways, but I'll take my whole numbers, multiply them together. I have 1/2 times 24, which means the area is, whoops, not a fraction, the area is equal to 12. Now usually we'll have units, centimeters, inches, and the way we can tell that we're dealing with area is that it's going to be centimeters squared. Whereas with a perimeter, perimeter, again, if we had some units, so let's just say all these were centimeters, we would just say it's 12 centimeters, straight out. There's no squared, all right? We're just talking about the distance around it. But here, we are talking about an area. Now, what can make these things a little more complicated is based off what the triangle looks like. But the thing is, we always need to know the height. So let's say we had a triangle that looked like this. All right, let's say we knew what this one was. That's 10. And let's say they even gave us this. They say this is 8. Well, we don't take 10 and 8 because 8 is not our height. Our height is from here to here. So we need to know what that is. And let's say that it's 7. So now what we can do is take these two numbers, the 7 and the 10, and apply them to the formula because this is our base and that is our height. So we'll go 1/2 times 7 times 10. And that ends up getting us 1/2 times 70, which is equal to 35. And again, it's going to be a unit squared when we give our final answer. All right, bear with me. One more thing. How can we make this harder? So let's say I have a triangle and you have a couple of the pieces. So it's something like 5, 13, and you're wondering what this is, and you're told the perimeter is equal to 30. Well, in a case like this, you can set it up. We have three things, the three side lengths are being added up and are equal to 30. So we'll take our unknown, put that there, and then the other two knowns we do have, and now solve. So x, combine our like terms, plus 18 is equal to 30. Subtract 18 from both sides, subtract 18 from both sides, and x has to equal 12. So that's how we can make a perimeter problem more complicated. For area, same idea. We can make these a little more complicated by giving a triangle. Let's go with a nice, they give us the height right here. Usually you'll see it maybe as like a dashed line or off to the side like that. And so let's say our base for this one is 8. They're not telling us what the height is, but what they are giving us is the area. And they say the area is equal to 24. And we have to figure out what's that missing side length. Well, we use the formula. Area is equal to 1/2 base times height. We plug in the information that we have. I know we have 24 is equal to 1/2 times 8 times our height. Well, now I just have to simplify some numbers. So I'm going to simplify my 8 and 1/2 and make that 24 is equal to 4 times h. In order to get h by itself, I would divide by 4. And now h equals 6. Box it, walk away. Now here's the thing. If these are units squared, this will just be a regular old unit. It's not squared anymore. So these are how we encounter and deal with some of the problems that we have with triangles. Let me know if you have any homework, or sorry, if you have any questions on your homework or practice, and good luck.